Okay, statistics, we're going to move into lesson 4.2 today, binomial distributions. So we're going to determine if a probability experiment is a binomial experiment or not. This will be the only skill we cover today. And then we'll move into finding probabilities. We are going to do probabilities by hand and also with our graphing calculators. So when it comes time to using those graphing calculators, I will give you the link so that you can download the Inspire software right onto your computer. And this would be for those of you that forgot to bring your graphing calculator home. But we'll worry about that in a few days. Okay, so let's go ahead and learn about probability experiments, whether or not they're binomial experiments or not. To be a binomial experiment, your experiment has to be repeated for a fixed number of trials. Each trial is independent of other trials. For example, maybe you're going to draw a card out of a deck of cards and you're going to draw a card out 6 times. That trial is repeated then for 6 times. That's a fixed number of trials. Let's say I'm trying to figure out the probability of getting a heart 6 times. So step 2 says there's only 2 possible outcomes. There's either success or failure. So in the example with my deck of cards, drawing out a heart would be considered a success. Drawing out something else that isn't a heart would be considered a failure. Number 3, the probability of success is the same for each trial. So we're going to do this experiment with replacement. If you did one without replacement, then this criteria number 3 would fail. Number 4, the random variable x counts the number of successful trials. So when I'm drawing out those 6 cards, or when I'm drawing out a card 6 times, I might get a heart 0 times, 1 time, 2 times, 3 times, 4 times, 5 times, or 6 times. All right, this is the notation. So if I go back to my card example, so I was looking at a deck of cards. I'm drawing out a card 6 times. I'm going to draw out 1 card, put it back in. I'm going to do this 6 times. Okay, so that's my experiment. All right, if I'm interested in the probability of getting 6 hearts, so the probability of getting 6 hearts, that's what I want to know. So every time I draw a card, I get a heart. I'm going to set up my notation to figure out that probability this way. The n is going to be the number of times the trial is repeated. So the n for our problem is 6. The probability of success in a single trial, that's my p. So that's the probability of getting a heart. There's 13 hearts out of 52 in a deck of cards, so that's 0.25. Q represents failure, so getting anything else out of the deck of cards. So that's going to be its complement, so 0.75. X, I could look at the probability of getting no hearts. 1, 2, 3, 4, 5, or 6. I will show you in the next video how to actually calculate this probability. But for today, what you're going to be doing is you're going to look at experiments and decide if they're binomial or not. And then if they are, you're going to be setting up these 4 things for each experiment. Okay, first example. A certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. So what you're going to do is you're going to go back to your criteria and you're going to make sure that your experiment fits all 4 criteria. So it's repeated for a fixed number of trials. you guys were, the problem said we're doing this on 8 patients, so 8 trials. Each trial is independent, so we're doing this on 8 different people. Either on number 2, either the surgery is successful or it's not. The probability of success is the same for each person, and so on. So here we go. This one is going to be a binomial experiment. All right, and so your N is the number of patients you have. It's 8. Your P is 0.85. It's right here. Your Q is 0.15. And your X, the number of successes, is anywhere from 0 to 8. All right, and they agree. These are the slides from the textbook that go through everything that we just said. Okay, moving on. This is another one. The jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. So that is key to this problem. The random variable represents the number of red marbles. Okay. If I do a probability experiment with this one, that sample space is going to change every time I draw out a marble because I'm not replacing. So this one is not a binomial experiment. It says the probability of selecting a red marble on the first trial is 5 out of 20. But because you're not replacing it, the probability of success for subsequent trials is no longer 5 out of 20. The trials are not independent of each other, and the probability of success is not the same. When you guys answer your homework questions, you are going to have to explain why it's not a binomial experiment for some of the problems. So make sure that you're able to communicate why some of these experiments are not binomial experiments. Okay, this is another example. You take a multiple choice quiz that has 10 questions. Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly guess the answer to each question. Now, I don't recommend doing this, but go with the problem anyway. The random variable represents the number of correct answers. Okay, so each question is independent of the others. For each question, you have a 25% chance of getting it correct, and that's because there's 4 answers for each. Only one of the 4 is correct. So our N will be 10. Our P is going to be 0.25. Our Q is going to be 0.75. And our X, you might not get any right. 1, 2, 3, all the way up to 10 questions correct. So this is a binomial experiment. All criteria are met. Okay, this next slide really has nothing to do with what we just talked about, other than if I assign, or I'm going to assign homework 4.2 part 1, and it's going to take you all the way through number 14. And the latter part of that first assignment has you finding the mean, variance, and standard deviations. So basically, you need to just have these formulas at hand so that you can calculate those answers. After I show you how to find a binomial distribution, then we'll come back and revisit this slide and actually calculate mean, variance, and standard deviation for a binomial probability distribution. So for now, just know that you're going to have these 3 formulas for this first homework assignment, which is 4.2 part 1. That's the end of your first video over lesson 4.2.